Hi everyone, this is the review video for your Unit 3 Trigonometric Identities test. Your test is super similar to the review, just like it has been in the past. There are, how many questions? There are 8 questions on it, and it involves content going all the way from proving trig identities up into like the law of sines, law of cosines, and area stuff for triangles. So the first couple questions are going to be proving a trig identity. They are not going to be the same questions, but they're going to be something where you have to use the Pythagorean identities or the ratio identities to get to a certain trig function. So for number 1, whenever you see like something squared on both sides of an addition sign or a subtraction sign, you want to look for the trig function that they both share. So for example A, they both share cosecant squared, which means I can steal a cosecant squared from both of those. So I'm going to divide both of these by cosecant squared. Okay, that cosecant squared does not just disappear. It's going to go into the front of a set of parentheses. So the cosecant squareds that are highlighted are the same thing. The first set are going to cancel. When it cancels, it turns into 1 because I'm dividing something by itself. Minus these cosecant squareds cancel, and I'm left with cosine squared theta. So if you look at your Pythagorean identities, 1 minus cosine squared theta is the same thing as sine squared theta. And then if you look at your ratio identities, you'll see that cosecant is the same thing as 1 over sine. So I can apply that even if it's squared. I just have to make sure that the sine is squared. Okay, so now I can cancel this sign, and I'm left with 1, and that was the number that I was trying to get to, so I proved that one. On example B, it's a similar idea where you're looking for the common trig function. Between these two, I can steal a sine x, so I'm going to divide both of these by sine of x. That sine of x doesn't just disappear. It's going to go to the front of parentheses. Here, we divide these out and get 1. These signs cancel, and I'm left with cosine squared x. So this is very similar to the last example we just did. Using that Pythagorean identity, 1 minus cosine squared is the same thing as sine squared. When you're multiplying something that is the same trig function, but they have different exponents, you add the exponents. So remember that it's not written here, but this is the sine to the first power. So this is the same thing as sine to the 1 plus 2 of x, which is sine to the third power of x, and that's what you wanted, so we've proved that one. Example C, this is one that was close to something that you had on your quiz. When you see two terms, or not terms, when you see two expressions being multiplied together, like 1 plus a trig function times 1 minus a trig function, you're going to think box method and multiply those out. If you can do this without box method and you can just write down the answer, I'm fine with that, as long as you show like at least one step in between. So don't just write, oh, it equals sine squared. Well, we know it equals sine squared, but how does that happen? So at least show me like one step in between. So if you're doing box method, I have a 1 and then a positive cosine, a 1 and a negative cosine. So I'm going to multiply the things in the box to get the middle. So 1 times 1 gives me 1. 1 times cosine theta is cosine theta. 1 times negative cosine theta, negative cosine theta. Negative cosine times positive cosine is a negative cosine squared. So looking in this box, notice that the two entries that are across from each other have different signs. So if I have a positive cosine and a negative cosine, they're going to cancel out, and we're just going to be left with 1 minus cosine squared theta. And using that Pythagorean identity, that gets us sine squared theta, and that's what we were looking for, so we've proven that. What I mean by if you're not going to show me the box, you at least need to show me this step here. If you're not going to show me the box, you at least need to write that part, okay? Okay, sum and difference. So there's two different methods that you can use. If it's not already in degrees, you can convert it into degrees and then use that to find your places on your unit circle. I don't like to do that, but just for the purposes of the video, because I know the majority of you like to do that, I'm going to do it both ways for the one that's in radians. So if you're going to convert to degrees, you're going to take whatever you were given in radians, so the 7 pi over 12, and you're going to multiply it by 180 over pi. So these pi's are going to cancel, and you have 7 times 180 over 12. That gives you 105 degrees. So you're looking for the sine of 105 degrees. So on your unit circle, you're going to be looking for two angles that are on the circle that add together to give you 105. I'm going to use 60 and 45. So since the trig function that you are using is sine, and you are adding the angles together, you're going to look for the formula, you're going to look for the formula that says sine of x plus y. Okay, so that's the formula that we're going to use. So I'm going to have sine, let's make x is 60 degrees and y is 45 degrees. So let's have sine of 60, cosine of 45, cosine of 60, and sine of 45. And then looking at your unit circle, you need to figure out what these values are. So like sine of 60, go to the angle of 60 degrees, look at the y value of the coordinate that's there, and that's the sine of 60. So you're going to get 1/2. Cosine of 45 is root 2 over 2. Cosine of 60 is root 3 over 2. And sine of 45 is root 2 over 2. And then you're going to multiply these together. So multiplying together, you're going to multiply the tops of the fractions together and the bottoms of the fractions together. So if you have 1 times the square root of 2, it's just the square root of 2. And then on the bottom, the 2 times 2 gives you 4. The other one, root 3 times root 2, is the square root of 6. You multiply the 3 and the 2 together and keep it under the radical. And then 2 times 2 gives you 4. So since they have the same denominator, you can rewrite these with one denominator of a 4 and then just have the 2 results on the top like that. So this would be your final answer. Okay. If you are doing this the other way, where you have to find 2 numbers on the unit circle in radians, I'm not going to do the whole problem. I'm just going to show you the first step. So you would take 7 pi over 12, and you would look for 2 things that add together, both having a denominator of a 12. That would give you 7. But both of those numbers have to be reducible by 12. So for example, you can reduce 2 over 12, 3 over 12, 4 over 12. You can't reduce 5 over 12. You can't reduce 7 over 12. So it has to be something that evenly divides into 12. So I'm going to take 3 pi and 4 pi. So when I reduce these down, you're going to get pi over 4 and pi over 3. And those are what you would use in your formula as x and y if you wanted to do it that way. Either way, you're going to get the same answer, though it doesn't matter. Okay, for part B, this is already in degrees. On your review, there is a typo and I fixed it on my key. This should be 255 degrees, not 155 degrees. So please change that if you're working through this as just a typo. So you're looking for two angles on the unit circle that add together to give you 255. I'm going to pick 135 and 120. If you wanted to take two angles from the circle that subtract to give you 255, or if you want to use a combination of other angles, it doesn't matter, you're going to get the same answer. So let's take 135 is x and 120 is y. So I'm looking at cosine, that is the trig function I'm looking at, and then I'm adding these two together. So on your formula chart, you're going to look for the one that says cosine of x plus y. Okay, and then I'm just going to go through and replace. So x is 135, y is 120. Okay, and again, you're going to look at your unit circle. So the cosine of 135 is negative root 2 over 2. Cosine of 120 is negative 1/2. Bring down the minus sign. Sine of 135 is root 2 over 2. And sine of 120 is root 3 over 2. You're going to do the same thing, and you're going to multiply, sorry, my dog's crying. You're going to multiply the tops and the bottoms of the fractions together. So on the first two fractions, a negative and a negative multiplied together are going to give you a positive root 2 over 4. Bring down the minus sign, and then you're going to get root 6 over 4, and then just combine those into one fraction. And that's your answer. So all of your sum and difference answers are going to involve a root 2, a root 6, and a 4 somewhere. If you get something that is not involving those numbers, like you get 10 somewhere in there, you did something wrong, so go back and look at what you did. If you want to write these in a different order, like you want to put negative root 6 plus root 2 over 4, that's also fine, as long as the sign in front of the root stays the same. So like here, this was a negative, it's still a negative. This was a positive root 2, it's still a positive. On the other example, you could also write this one as root 6 plus root 2 over 4. They both have the same sign. So either of those are acceptable answers. Okay. Moving on to double and half angles. This is something that I think is one of the hardest concepts for us to grasp, just because it involves so much critical thinking for a problem. So I try to make it as easy as possible on you by giving you a Pythagorean triple for each problem, so that way you don't have to do any crazy solving stuff with Pythagorean theorem. So the first step in these is that you need to figure out the boundaries that you're between. So for this one, you're between pi over 2 and pi. So pi over 2 is here, and pi is here. So I'm going to draw a triangle between those two, and this is a right triangle. The ratio for sine, so sine theta, the problem tells us that it's 3 over 5. Remember, you're going to use SOHCAHTOA. You can use that to help you remember. So sine is opposite over hypotenuse. So if I'm drawing the angle, the side that you land on is adjacent. So that side that I landed on is not 3 and it's not 5. This is the adjacent side. We don't know what it is. The hypotenuse is always across from the right angle. That's 5, and then my opposite is 3. So you're looking for that missing side. The Pythagorean triple for this one is 3, 4, 5. So those numbers always go together. So the missing side is 4. Okay, so I'm not going to look at your drawing of the triangle, really. I'm not going to grade that part. It's just if you need visual help. So in order to use, what I'm looking for is the sine of 1/2 theta. In order to use that, I'm just going to write the formula out. In order to use that, I need cosine theta, but I don't have that. So cosine is adjacent over hypotenuse. My adjacent side is 4, and my hypotenuse is 5. I'm sitting, the triangle that I drew is in quadrant 2. In quadrant 2, if you look at your unit circle, all of your cosine values are negative. So that means that this cosine needs to be a negative 4/5. So we've got half the battle done. The other half is figuring out if I'm going to use the plus or the minus sign that's in front of that radical symbol. And that comes by getting your boundaries multiplied by 1/2. So you're going to take the original boundaries that it gave you, so the pi/2 and pi. And since you're looking for half of theta, you're going to multiply pi/2 by 1/2, theta by 1/2, and pi by 1/2. Okay. Again, you're multiplying fractions, so you're going to multiply straight across. So pi times 1 is pi, 2 times 2 is 4. The 1/2 theta stays. And then pi times 1/2 is pi/2. So if you're sitting at pi/4, you're somewhere here, and then pi/2 is up here. So you're sitting in quadrant 1, and the trig function that I'm looking for is sine. So you are trying to see if sine in quadrant 1 is positive or negative. Well, it's a positive number, so I'm going to take the positive version of that formula. So you've got positive 1 minus cosine over 2. And then I'm going to substitute my cosine value of negative 4/5 into my formula. And you just type that in your calculator. And I got about this number. Or some of you might have 3√10/10. So either of those either of those numbers, depending on what your calculator gives you, is fine. Okay, the next one. This one is actually quite simple if you know the correct formula to use. So you're looking for cosine of 2 theta. If you look at your formula chart for double angles, you have 3 different formulas that you can use for cosine of 2 theta. Look for the one that only involves cosine, because you were already given that piece of information, and if that's all that formula needs, then you don't have to go through a whole bunch of other work to find out. So cosine of 2 theta, looking at the formula that just involves cosine, is 2 cosine squared theta minus 1. So I'm just going to replace that cosine squared theta with the 12/13, and I'm going to square that. Like that. You type it in your calculator, and you're going to get 119/169, or as a decimal, you might get this. So either one of those answers are fine. So if you are working smarter, not harder, you can find the formula that is simple to just kind of plug and chug with that. And you don't have to draw a picture or worry about boundaries or anything like that. The double angle problems, you do not have to multiply the boundaries by 1/2 because the formulas do not have a plus or a minus sign in front of them. But the 1/2 angles, you do have to write a plus or a minus in front of them. So that's when you're multiplying the boundaries by 1/2. All right, moving on to law of sines and law of cosines. So your test is going to tell you which method that you need to use to solve it. So for this one, we are using law of sines, and we're solving for side B. So I'm just going to add some extra labeling here so it's super clear what's what. Okay, that's it. So with law, with law of sines, we're looking for side B. So the part of the formula that I'm going to use is little b, the side that I'm looking for. Remember that small letters are sides and big letters are angles. So I'm going to take little b over sine of big B because I am looking for side B. That's why that's my first fraction. I'm going to set it equal to a letter that I know the side and the angle for. So in this case, I know side A and I also know angle A. So I'm going to just rewrite this formula and substitute. So little b, I don't know what that is. That's what I'm looking for. Angle B is 42. Side A is 31. And angle A is 64. So notice that the only letter that's left in there that I'm solving for is B. So whenever you're setting up your law of sines ratios, you should only have one letter that's left over. So you're going to cross multiply these together. So I've got B times the sine of 64 equals 31 times the sine of 42. My goal is to get B by itself. So I need to undo the multiplication of B times the sine of 64. So to undo that, I'm going to divide both sides by the sine of 64. So these cancel. So what you're typing into your calculator is this. And you should get about 23.079. I'm not going to be super picky about your decimals, but if you could go at a minimum at least 2 decimal places, like do not round this to just 23. At the most, you could round it to 23.08. But give me at least 2 or 3 decimal places. Don't round it to the nearest whole number. Okay, number 6. Now we are using law of cosines. So if we are looking for an angle, and I'll label this real quick. Okay, if we are looking for an angle, on your formula sheet under law of cosines, you have 3 different formulas that say cosine A, cosine B, cosine C. Since they have a big uppercase letter that goes with them, that's the formula that you're going to use if you're looking for an angle. If your test says find the missing side, you have 3 formulas that say a squared, b squared, c squared. That's the formula that you're going to use since they have a little lowercase letter first. So I'm going to, my missing angle is A, so I'm looking for cosine of A. I'm just going to copy my formula from the formula chart. Okay, so since in my formula all of these are lowercase letters, that means you're only using the side measurements. You're not going to put any angle measurements in here. So that angle B of 97 degrees, that's not going to go into your formula here. Okay. So when you type that into your calculator, you're going to get about this number. And that is not the end of the problem. What you just found is the cosine of angle A. I want angle A, not the cosine of the angle. So you're going to take the inverse cosine of the number that you got. And that is going to give you 58.99 degrees, and that is your angle A that you were looking for. And that's all you have to do for that one. Don't round it up to 59, just leave it at 58.99. All right, we are on the last 2 problems. These are actually really easy. They're just like plug and chug. There's really not a whole lot of critical thinking that goes with these. So I told you on your review what formula that you're going to be using. on your test, I may not give you that. You may have to figure out what formula it is. So hint, hint, look at the review and see that you should be using a certain formula. So you have 3 different options for area formulas if you are given 2 sides and an angle in between those 2 sides. It's just a matter of how you label the triangle. So you can use any of the 3 formulas. Really all they're doing is taking a half of the product of the 2 sides times sine of the angle that it gives you. So in this case, I'm going to have 1/2. I'm going to label. So side A is 15, side B is 12, and then I'm going to take the sine of angle C, which is 82. You're just going to put that into your calculator, and that is the answer. That is all that you have to do for that problem. Number 8. So this one says using Heron's formula. That's like at the, I think it's like the bottom of your formula sheet where it has the area formulas. This is kind of a 2-step problem. So the formula for area using Heron's formula is this. And you have to find S in order to use the formula. I'm gonna label the sides real quick. I keep forgetting to do that. So S is half the sum of the 3 sides. So I'm going to take half of 26 plus 24 plus 18 and type that in your calculator. It gives you 34. So wherever I see an S in Heron's formula, I'm going to replace it with a 34. So I've got 34 minus side A, which is 26, 34 minus side B, which is 24, and then 34 minus side C, which is 18. You can put that all in your calculator at one time. Just make sure you put it under a square root symbol, and you get 208.614, and that's the answer. So if it asks you to use Heron's formula, you have to find S first, and then put that into your formula, and then you can type it into your calculator. So that is the end of your review. I tried to make this test as easy as possible with all of the information, because I know that this is a lot of different concepts for one test. So please come in for tutoring prior if you need help with understanding the material. Your test is on Wednesday, so that way we can go into break, not having to worry about testing or forgetting material or anything like that. And after this, you are done with Trig. So congratulations, you have made it through that part. And I know that was a big struggle, so congrats. I'm really proud of you guys. So let's get 100 on our test. Have a great night.